Loading. Okay. See, number one, when you are plotting, everybody able to see the screen?
Yes, sir.
Okay, sir. See, number one, when you are plotting this one, all these curve should have the same x-axis and y-axis. That is very important. Please don't let in case if the axis of each of them change, then you can't do coordination. Okay, that is one thing. And one more thing, see what I want to tell you is now here this is the curve for the outgoing feeder, the orange one. The outgoing feeder is what is the rating of the outgoing feeder? You let us see the rating of the outgoing feeder. Outgoing feeder, yeah. You are able to see this single line diagram. The outgoing feeder here is 400 kilowatt motor, right? 400 kilowatt, the motor at 60, how much? 60, 400 kilowatt motors will be how much? What will be the current? 44 amps, right? So what will be the CT rating? What will be the CT rating? Anybody? Pinaki
So
ji.
we can take 75 or 60 bar 1 if it's available.
Okay, 50 or 75, anything, okay? So,
Yes, sir.
okay. Suppose, so if this is 50 amps, so then what you have to do, the pickup current is 44 amps divided by 50 amps, okay? See, actually, the each of the curve that you are going to plot on the TCC, it has to be with respect to its CT rating. Okay, because the relay will actually see if you are a relay guy who has made the relay basically you input even the CT primary and secondary rating to the relay. So for the relay, the pickup current, all those things, it will is based on the CT primary rating. Okay. So in that case, what I have to do is I have to actually now here this orange curve, orange curve. Let me go and see what is this orange curve. It is the outgoing breaker rating. So the outgoing breaker rating is how much? 44 amps. It has to be how much? 44 amps divided by, let's say the CT is 50 amps, okay, into 1.1, okay, so it will be 0.968, okay, so this has to be it is not 0.645, see it has to be 0.968, okay.
Yes, sir.
Uh, okay, now, okay, so now I have plotted so let me go. So see here, the outgoing curve is coming above the incoming curve. The outgoing curve has to come below the incoming curve, right? So what I do is I will just change the TMS in order to suppose see the curve has to come below. If the curve has to come below, it means for the same current, it has to see for the same current here, no? For the same current, you are able to see my Excel file, right?
Yes, sir.
Yeah, for the same current here, it has to operate in a lesser time, right? It has to operate in a lesser time. In order to operate in a lesser time here, I have to reduce the TMS, okay? So I make TMS2. Yes, but here you see there is a problem here. Okay. Now, what is the pickup here? The pickup, what is the CT rating in the primary? The CT
You've
rating,
reduced it further, no, sir. You have to increase that further or something.
yeah,
Because if this is 0.6, then that should be 0.7 or something.
yeah. No, pickup, see, pickup
You
of
have
the
to increase
in
it, no?
pickup of the
It has to be
incomer.
more than your, yeah.
No, pickup
Your,
of the incomer. I have
has
what
to
is the
be,
this is pickup of the motor
pickup of this
and
outgoing
say,
pickup has to be increased, sir, I think.
no, outgoing pickup, if I increase, no, this orange curve will move further right side. Okay.
That's what we want, no,
So,
sir.
what we see, no, orange curve has to be left and below. Okay. So now
No, if
what
you keep the
was,
orange curve left, sorry, sir, if you keep the
yeah,
orange
yeah,
curve left, that's the
yeah.
outgoing, no, sir. So
Outgoing,
then it'll trip before the incomer then.
no, no, no. See, anything for any, if it is the left and below, it will trip first.
Yeah. So you push that
The
one, the one that you
no,
don't want to trip to the right, or you push
no,
the
no.
blue colored one to the left.
Orange curve is the outgoing feeder, and outgoing feeder has to trip first.
Yeah. Okay.
And if the outgoing feeder has to trip first, it has to be the left hand at the bottom.
Okay.
Okay. So since it has to be in the left hand bottom, see if my fault is here, let's say my fault is here 5 times the current, and at
Okay.
that time first this fellow will act, then this fellow will act. Okay.
Okay, sir.
Okay. So now, what was the transformer rating? Transformer rating was 5 MVA, right?
Yes, sir.
So 5 MVA at 6.6 kV is how much? 6.6 kV. What is that? Some sound. Please mute. Please mute. Somebody. Some sound is coming.
438 amps, sir. 5 MVA.
Okay. 5 MVA is 438 amps. Okay. So now, what was the CT we selected?
500 bar 1.
500 bar 1. Okay. And okay, into, let's say, I take it 1.1 one time. Okay. So what will be my pickup? 9636. Okay. So my pickup is 9636. See, actually, many mistakes that we do only after we plot, we will come to know. Okay. Sometimes, and okay, so now it is fine. Okay. Now, next thing, last time, what was the curve I had chosen? Okay, last time, let me go back to the PPT. Now here, uh, last time, Lognathan sir, what was the curve we chose last time?
Normal inverse, sir.
We chose normal inverse.
Yes, sir.
So it was 0.02 alpha and 0.14 beta, right?
Yes,
So
sir.
now let's see 0.02 alpha, 0.14 beta. Let's see. And Suppose, okay, 0.02 alpha, huh? I take 0.02. And what is beta? Beta is 0.14, right?
Yeah.
Beta is 0.14. Okay. Here also the second curve also I will make 0.02 alpha and beta is 0.14. So you see what happens here. The relay curve is actually cutting your transformer curve. Okay. So that's why instead of going for normal inverse curve, I have changed it to very inverse curve where alpha is 1 and beta is 13.5. Okay. Alpha is 1 and beta is 13.5. Okay. Alpha is 1, beta is 13.5. Okay. Okay. Now, what is the okay, let's go here back to the PPT and see. Okay, in this single line diagram, are you able to see the single line diagram? What is the size of the cable here? Outgoing feeder. Are you able to see the outgoing feeder cable size?
50 square mm.
50
Copper.
square mm. Yeah, 50 square mm copper. So 50 square mm copper, what is the short circuit rating approximately? I think 7.5 kA mostly for 1 second. Okay. So now let me plot I square T rating of a 50 square mm cable. Okay. So I go here, I2T, I2T curve. You're able to see Excel file
Yes, sir.
for MM cable. Okay. So what should be the this one? What is it? 7.5 kA for 1 second, right? So it is I square T. So if the time changes, what is this one? So I square T is how much? 7.5 square into 1. So this is constant. Okay. Now suppose I enter the time T as 1. Okay. Then how do I get I? How do I get I? I square T divided by T square root. Okay. So I square T, let us say I square T. Um, let me divide
You
it.
can come back to 56.25 only, sir. I
Pardon?
think you have to take a different one. One of the values has to be different, otherwise
No,
it'll
no.
come back to the same value.
I'll explain you why I'm telling like that. Take I square T divided it by T. Okay. And you take the square root of this.
Come back 7.5 only, sir.
Yes. I know that. Take square root of it. Okay. So you got 7.5. Now, what do I do? Let me copy this again here. Okay, let me take this as this. Now, let me change the time. Okay. Uh, suppose my cable for 2 seconds. Okay, maximum. Let's say for 10 seconds. What will be this one? Okay. So here, see the cable. If it's up to what is the let me draw, let me say 50 seconds. Okay, let me see 50 seconds. Okay, it can take up to now. let me plot again. Okay, let me make this 45 seconds. Okay, now let me plot this. uh, Okay, 45 seconds up to, okay, let me remove this from here. Okay, zero, no, not zero. Let me then go for 4 seconds. Let me go for 3 seconds, 2 seconds, 1 second. Let me go for 0.7, 0.5 seconds. Let me check what is the so 3.3 second means 300 milliseconds. For 300 millisecond, my 50 square cable will be able to carry 13.69 kA. Similarly, for point 2 and point 1. Okay. So basically, this table is giving you the this one. How much short circuit current the 50 square cable can carry. So at 0.1 second, it can carry 23 kA, right? Now, this is what, now I have to plot this, right? I have to plot this. Let me see. Pinaki ji, you can mute for some time. Later on, you can unmute yourself. Okay, thank you, sir. Thank you very much. Okay, now I need to plot this curve, okay? So whenever you are plotting any curve, so let me copy this. Okay, let me write here. See, when I plot sheet 1, so x-axis has to be the current, and sorry, x-axis, yes, x-axis is current, right? And current is what? D, D, E, B, C, D, E. So here, let me check the data once. Let me say select data. Suppose I have my incomer. So x-axis is F, y-axis is G. X-axis is F, that is x-axis is current, F, y-axis is G, time. So the same way I will do here, x-axis as current, which is E. So I make this as E, and y-axis is time, which is F. So I make this F, okay. And the range, I want it to be from 101 to 119, okay. So I make this 101 and I make it, sorry, 119. Similarly, I make this also 109. I make this 119. Now I need to add a curve here, right? So how do I add a curve here? Right click, I say, right click here, I say, just now I had done, no? I had added, okay. Select data, and here I say add, okay, add. What is the name of the curve? I say cable damage, or a cable I2T, also I square T curve, I2T. Which cable? It is outgoing cable, OG cable, outgoing cable, okay. So what is the x-axis here? I have seen here. So let me write down this. It will be sheet 1. Then I add this apostrophe and then dollar sign. Then E, again dollar 101, 2, again dollar E, dollar 119. So 101 is the first cell from where I have to take the data, and 119 is the last cell up to where I have to take the data. Similarly, in the y-axis, instead of E, I will have F, because F is a row which corresponds to time. Okay, so I got it. So let me see how it looks. Okay, so this is the cable damage curve. My orange curve is the outgoing, right? Outgoing. Yeah. So one mistake, let me tell you. See, the current here is in kiloamps. Current should not be in kiloamps, right? Current has to be in per unit value. So if I say per unit value, 7.5 kiloamps, I have to divide it by what? The CT. I have to divide. So basically, this has to be divided by the CT. So 1 kiloamps. What is 1 kiloamps? How does the relay see 1 kiloamps? For relay, what is the CT rating of the outgoing feeder? We took it as 50 amps. So it is 1 kiloamps is, this is 1 kiloamps. Divide this by 50 amps. Okay. So basically the relay will see it as 21. Okay. So my current axis has to be the per unit current. And when I say per unit current, the base is the CT primary rating. Okay. So here I did a mistake here. I took the absolute current. Let me change this curve. So insert, let me plot the per unit current. Okay. So what is the per unit current? It is given by the rho G. So let me go here. You select the curve, right click and say select data. I go to this, I say edit, and where is the x-axis? Here. Instead of E, what is the x-axis? What is the x-axis? X-axis is the current, right? X-axis is the current. EFG. Oh, I think some mistake. X-axis. What is x-axis? X-axis is time. E is time. E is time. G is current. So let us see whether we have
So you
done
can
it right.
write then also. I want to help out. I mean,
Pardon?
sorry, nothing, sir.
Yeah. E is time. G is current. So this has to be G. X-axis. This has to be G. G. Okay. X-axis is the current, and current is given by the rho G. And y-axis is the time, and time is given by the rho E. So this has to be E. This has to be E. Okay, so now, okay, let's see how the curve looks. Okay, where is the curve now? Invisible. Oh, what happened? Okay, it started from 21 times. Okay, so 21 to 473. The current, what is the current here? The current here stops at 10, right? So let me go here. If the current is okay, 7.5. So I started from how much? What is the current? This is what? What is? Mm, I took this 50 second, right? So at 50 second, for 50 seconds, the cable can take 1 kiloamps, right? Right. And 1 kiloamp corresponds to 21. 21. So if I want to plot in this curve, I need this one below 1 kiloamp. Suppose I am going to load the this one. So let me do one thing. Let me try to add some more cells. Okay, here I will try to add some more cell here, like let's say 55. Okay. Okay. Let this be 55. Let this be 60, 65, 70, 75, 80. See, after this, I will ask you and we will interact. Okay. So don't think that I am rushing and you are not able to ask anything. Okay. 105. Hmm. So this is 14 times. I will make this 60, 55, 65. I will make this 75, 85, 85, 105. Then I make this 120. I make this 150. I make this 200. I make this 250. Okay. Or I make this, let's say, 500. Or I make this 1000. Mm, I make this 2000. I make this 5000. I make this 2000. I make this 1000. So basically, what I'm trying to see is if I overload my cable continuously for 5000 seconds, what is the amount of current it can take? So it can take 2.2 times. Okay. If I overload my cable by 1000 seconds, the amount of current it can take is 4.4. So 500 seconds, 250 seconds, 120 seconds. Okay, so now let me try to plot from this 101 to 129. Okay, let me try to plot from 101 to 101 to 29, right? Instead of 111, I make it 101. I make it 101. Okay, let's see. Okay, where is the curve here? Why the curve is not seen? Now it should be seen, right? Select data, edit 101 to 129. It should have been visible 500 times. Okay, okay. 101. So let me do one thing. Let me try to plot. Okay, plus 101 to 20. So the column G corresponds to, okay, column E corresponds to the time, which starts from 0.1 second to 5,000 seconds. So 0.1 to 5,000 will, okay. And column, this one, column G corresponds to the x-axis, and x-axis here comes from 2 to 470. So 2 to 470. So something should be visible here, but why the data is not coming? Let us check. Select data. Okay. Edit. G. X-axis is what? Sheet 1 apostrophe $G $101 to $G $129. Sheet 1 apostrophe $E 101 to $E $129. I think there is no problem here. Okay, I say okay. See, it says outgoing cable. I think let me change the color. 1, 2, 3, 4, 5. 1, 2, 3, 4. I think let me change the color of this outgoing cable. Data, select data, outgoing cable. That's style, filters. This is the, okay. Let me remove all this. Okay. Where is my outgoing cable? Okay.
Sir,
Yes, sir.
you can in top left corner you will find the color.
See, actually
Below insert.
here the curve is there. See, outgoing cable is showing as blue color here. Okay. So the curve is there here, but the okay. So let me do one thing. I will change the color of the outgoing cable to red.
Sir, I think this curve is going out of this table. I mean, because it is
Actually,
only 10 amps on the x-axis. We have
you're correct.
5,000 amps.
Yes, sir. See, from 2.2 up to 470, I'm having here. So 2.2 to 470 means up to something is there here. You know, it starts 2.2 starts here. So it should be there here. And you see here, the time is,
Because of the time, it is fine.
yes, sir, time is how much? 5,000, 2.2 is 5,000, 470 is 0.1. So 5,000 is above, 0.1 is here. Okay. So basically see, I just want to see whether my orange curve is below the cable damage curve. Okay. So it appears that that is what I am trying to see. Whether so what I will do, I will try to plot one more Excel file where I will plot this orange curve and the cable damage curve separately. Okay. Let me, so here I will remove this curve. I will remove this blue curve. I will remove the red curve. Okay, and now I will make this automatic. Okay, I will change the chart type. Sorry, I will change this format axis. I will say how much. Let's say the maximum. Okay, I just reset. Now you see my cable, the TCC of the outgoing feeder is below the cable damage curve. So it is okay. Okay, so you have to basically ensure that your TCC is always below the damage. For an outgoing feeder, the TCC has to be below the I square T rating of the cable. And for an incomer feeder, that is this blue one, the TCC has to be below the transformer or the generator damage curve. Okay, this is what I wanted to explain. But because of this axis, I am not able to plot here. Okay, so okay, what we do here is, okay, we will close it for here today. And please post all your query in the WhatsApp. And tomorrow is fully, we will keep the first 30 minutes for clearing your doubts. I will share this Excel, I will share the PPT. Go through and ask me the doubts tomorrow morning, the first 30 minutes. And then later on, we will take up symmetrical component tomorrow. On the board, I will draw and explain how via symmetrical component you can do the fault calculation. Okay. Okay, sir. Okay, this one? Okay, Mr. Gaurav, Mr. Loganathan, Mr. Pinaki, Mr. Naveen Kumar, Mr. Vijay.
Yes, sir. Thanks.
I see, I understand today the session was bit fast. Last session was slow.